In Lesson 6.2, we're solving inequalities by multiplication and division. You'll learn to solve linear inequalities by using multiplication and to solve linear inequalities by using division. Why are inequalities important in landscaping? Isabel Franco is a landscape architect. To beautify a garden, she plans to build a decorative wall of either bricks or blocks. Each brick is 3 inches high and each block is 12 inches high. Notice that 3 is less than 12. A wall 4 bricks high would be lower than a wall 4 blocks high. 3 times 4 is only 12, but 12 times 4 is 48. So because the original relationship was a less than relationship, multiplying it by 4 left it a less than relationship. Let's start off with an easy less than relationship. They did, all right, fine. 3 is less than 12. We can agree on that. Now, if we multiply both sides by -1, we'd have -3 and -12. If we looked at those numbers on a number line, -12 would be further to the left than -3. So -12 is now less than -3, or we could say -3 is greater than -12. So when we multiply or divide by a negative, it reverses that inequality relationship, so we have to flip our sign around. Now looking back at their example, they multiply both sides by 4. We didn't have to reverse our inequality. So if each side of a true inequality is multiplied by the same positive number, the resulting inequality is also true. If a and b are any numbers and c is a positive number, the following is true. If a is greater than b, then a times c is greater than b times c. And if a is less than b, then a times c is less than b times c. If each side of a true inequality is multiplied by the same negative number, the direction of the inequality symbol must be reversed so that the resulting inequality is also true. If a and b are any numbers and c is a negative number, then the following are true. If a is greater than b, then a times c is less than b times c. And if a was originally less than b, then a times c is greater than b times c. And both these properties are also true for greater than or equals to and less than or equals to. To undo the divide by 3, we're going to multiply both sides by 3. And because we multiply by positive, we don't have to reverse our inequality, so we're just going to have g is less than 36. Now it's always a good idea to check. Because this is an inequality, I can pick anything I want that works. So I like to pick 0 if I can. So I'm going to check with g equals 0. So 0 divided by 3, is it less than 12? 0 divided by anything is 0. 0 is less than 12. So I know my inequality is going the right way, and I should be right. If I want to get rid of a fraction, we're going to multiply both sides by its reciprocal. So the reciprocal of -3/4 is -4/3. And I'm going to put that over 1 just to make it easy to multiply. Cancel, 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 cancel. I can cancel the 3 and the 6. So I have d. Now I multiply both sides by -4/3, so I need to switch it to is less than or equal to. 2 times -4 is -8. Okay, so I need to pick a number less than -8 to check. I'm going to pick -20. I wanted a multiple of 4. So I hope that is greater than or equal to 6. The 20 cancels with the 4. So I have negative times negative is a positive. 15 is greater than or equal to 6. Yes, it is. Now, just because there's a negative somewhere in the problem, we don't necessarily have to change the inequality around. So they threw in this one. If we have x divided by 6, I'd want to multiply both sides by 6 to undo the divide by 6. So I get x is greater than -18. So this time I did not reverse the inequality because I multiplied by positive 6, even though there was a -3 sitting there. Now we're going to practice our word problem skills, our translation. Write an inequality for the sentence below, then solve it. So 4/5 of means times a number they picked r for their variable is at most, remember, is less than or equal to 20. So once again, to get rid of a fraction, we're going to multiply both sides by its reciprocal. And we can cancel, and we can cancel. And all I have left is r is less than 5 times 5 is 25. And it's always a good idea to do a check, so I'm going to check with, and it says r is less than 25, so I'm going to check and see if r equals 0 works. So if I do 4/5 of 0, will it be less than 20? Sure. Now, we've really been using division already when we're multiplying by the reciprocal, because that's the same as dividing. But just in case, if each side of a true inequality is divided by the same positive number, the resulting inequality is also true. And if each side of a true inequality is divided by the same negative number, the direction of the inequality must be reversed so that the resulting inequality is also true. I want us to solve, so to get rid of times 12, I'm going to divide both sides by 12. So I have s is greater than or equal to 5. I'm going to check that with a number, I don't know, bigger than 5. How about 10? Picking easy numbers. So 12 times 10, is that going to be greater than or equal to 60? 120 is in fact greater than or equal to 60. I'm going to follow the directions, even though it seems a little silly, solve using two methods. So my first way I would undo multiply is by dividing both sides by -8. And when we divide by a negative, we have to reverse our inequality. So 136 divided by -8 is -17. Or instead of dividing by -8, that would be the same as multiplying by -1/8. It doesn't matter. I still get q is greater than -17. One answer, two ways. This is a really sneaky way of writing a multiple choice question. They gave us 4 possible answers that are really inequalities we have to solve. Very sneaky. Okay, so we're going to start with A. Why not? -2x is less than -12. If I divide both sides by -2, I get x is greater than 6. Okay, so A worked. Moving on, we'll try B. -6 is greater than -72. Divide both sides by -6, and I get x is greater than 12. Well, that wasn't horrible. I guess that one didn't work. We could keep going, I guess, if we want to, because it's fun. For C, 5/6x is greater than 5. So I'd multiply by 6/5. 6/5. 5's cancel out, so I get x is greater than 6 again. And we need to do D yet. Why not? -1/8 x is less than -3/4. So we'd multiply both sides by -8/1. And cancel. We have x. We have to reverse the inequality because we multiply by a negative. Is greater than. The 4 would cancel with the 8. Negative times negative is a positive. And what do you know? So the only one that did not give us x is greater than 1/6 was B. And here's your much anticipated summary. If we're solving inequalities by multiplication and division, if each side of a true inequality is multiplied or divided by the same positive number, the resulting inequality is also true. If each side of a true inequality is multiplied or divided by the same negative number, the direction of the inequality must be reversed.